So this video is regarding the period of trigonometric functions, and we're going to basically look at sine. Sine is our sine. We'll also look at, I guess, tangent if we have, if I make the time. But remember, this applies to sine, cosecant, secant, cosine, and tangent and cotangent. Like all of these transformations, they apply to all of them, even if I'm focusing on sine during this video. So this blue function is our parent function. Note that it starts at 0 here and ends at 2 pi, which means it has a period of 2 pi. Parent function does. And it is bounded by 1 and -1 in its height or range. And this b value is the number that affects our period, or how long it takes before this function repeats. Again, in this case, 2 pi for the parent function. So what we're going to do is we're going to put an example together where I have y, for instance, y equals sine 2x. So my b value is equal to 2, and this is how we calculate the period. The period of our function is going to be equal to 2 pi divided by 2. So in this case, my period for this pink function is pi, because the 2 is equal 1. So that means it's only going to take a distance of pi along the x-axis for my function to repeat. Since this is still the sine function, it's going to look something like this. Okay? So it looks like that. Notice how it's half the length of the blue one. Again, it repeats forever on to the right and to the left, but one period is half the length of the blue one, or parent function. Let's change colors. Take a look at y equals sine 4x. To calculate the period, we're going to have to pull the b value out. In this case, it's 4. And so the period is equal to 2 pi divided by 4, which is pi over 2. That means it's going to take pi over 2, the distance of pi over 2, for the function to repeat. So it ends up looking like this. And so notice how it is 1/4 the length of the original blue parent function's period. So what hopefully we're actually observing here is, if I had a b value of 5, then my period is going to be 2 pi over 5, or you can think of it as being 1/5 the original period of my parent function. If it was 7, if b was equal to 7, then it's going to be 1/7 the original period. Okay? Because we're dividing. We're dividing by that b value. And in contrast, if I had, for instance, a function y equals sine 1/2 x, we're going to divide the original period, 2 pi, divided by 1/2, which is the same as 2 pi times 2 over 1, which is 4 pi. So when my b value is 1/2, I'm going to double the period of my function, so it ends up looking like this, or at least half of the period looks like this. It's going to take 2 pi just to go half of the cycle. So that's how the b value works, and that's how we calculate it. Now, how does that affect, or how's that changed when we talk about tangent and cotangent? I'm hoping you to tell me, well, the original period of tangent is, the original period of the parent function y equals tangent x is pi. So the calculation is exactly the same, except for we don't have the same initial period. So the period of the tangent function, and consequently the period of the cotangent function, is calculated as pi over the b value. And it works the same way. If I have b is equal to 7, then my period is pi over 7, which is 1/7 of the original period. Okay? Hopefully that's helpful. And then we'll have one last video where it pulls all 4 of those together, and we'll graph one as an example. All right? Take care. Bye.